Hello friends, so today we will discuss a problem on continuity again. Okay, so previously we discussed one problem in the last video. So here you see a function is given sine 3x plus alpha sin x minus beta cos 3x by x cube, and given that it is continuous at x equals to 0. If it is continuous at x is equal to 0, what is the value of f of 0? So whenever a function is continuous at a point, limit value equal to function value. So here it says that f is continuous at x equals to 0. If f is continuous at x equal to 0, limit value should be equal to function value. So function value at 0, f of 0, should be equal to limit value. Limit extends to 0, f of x. So the value of f of 0 is nothing but the limit value. So we calculate limit. Limit extends to 0, sine 3x plus alpha sin x minus beta cos 3x by x cube. Now here you see we have x is moving towards 0. If x is moving towards 0, if you substitute x equal to 0, direct substitution if you do, sine 0 is going to be 0. This is also sine 0, 0. And cos 0 is 1. Cos 0 is 1. So numerator value is going to be finally minus beta. And of course x cube is 0. So we are going to get minus beta by 0, which is infinity, if beta is not equal to 0. So if beta is not equal to 0, we can say that the limit value is infinity. So it's undefined, the limit value is not defined. So if you want to get the limit value, beta should be 0, so that we got a choice. We will get a chance that 0 by 0 form you have in limits, we use L'Hopital rule. So therefore here for the existence of limit, what we do is we take beta is equals to 0. So then the limit will become, limit extends to 0, sine 3x plus alpha sin x, and beta is 0, so that beta cos 3x term is gone. You'll get by x cube. Now it is in the form of 0 by 0, indeterminate form. We can use L'Hopital rule. So limit extends to 0. L'Hopital rule says that differentiate numerator and differentiate denominator. Sin 3x derivative cos 3x into 3x derivative 3 plus alpha into sin x derivative cos x by x cube derivative is 3x square. Now you see, again we substitute x equal to 0. So you get here 3 plus alpha in the numerator, 0 in the denominator. So once again this 3 plus alpha should be 0, right? So that we'll get a choice to calculate the limit. If 3 plus alpha is 0, it is in the form of 0 by 0. So if 3 plus alpha is equal to 0, that means alpha value is minus 3. So we got the alpha value now. Alpha value is minus 3. You copy this alpha value in limit here. Here alpha is minus 3. So if you write that alpha minus 3 and you take 3 common, limit extends to 0. If you take 3 common, what do you get? Cos 3x. Alpha is minus 3. You substituted minus 3 here. So 3 taking common, we get minus cos x divided by 3x square. So 3 cancelled. We got cos 3x minus cos x by x square. So again it is in the form of 0 by 0. So one more time you can use this L'Hopital rule. Cos 3x derivative minus 3 sin 3x and minus cos x derivative minus sin x. So minus of minus plus sin x divided by x square derivative is 2x. Okay, so you write 1 by 2 outside of the limit. This 2 I am writing outside of the limit, and separate this x so that we get standard formula, that is minus 3 sin 3x by x separate, plus separate in the denominator sin x by x. Okay, so here you see multiply with 3 and here you divide with 3. So somewhere I'll write here, okay, minus 3, and here sin x by x, it's as it is. Limit theta tends to 0, sin theta by theta is equal to 1. So this is in the form of limit theta 0 sin theta by theta. So half of minus 3 into 3 minus 9, sin 3x by 3x 1 plus sin x by x is 1. So which is half of minus 8, which is equals to minus 4. So here we used what? We used two standard formulas. Limit theta tends to 0, sin theta by theta is equals to 1. And one more, we used the L'Hopital rule. or L'Hopital rule. So when we use L'Hopital rule, if you are trying to find limit extends to a f of x by g of x value you are trying to find, you are trying to calculate this limit value, but when you substitute you are going to get 0 by 0 or infinity by infinity, then we use this L'Hopital. Okay, so this is simply depend on continuity definition. A function is continuous at x equal to 0 means function value should be equal to limit value, right? So let's check one more problem. See this problem. F from open interval 0 comma pi to r is defined as c 8 by 7 to the power of tan 8x by tan 7x in between 0 to pi by 2, and a minus 8 simple constant whenever x value is pi by 2. What is the meaning of x is pi by 2? Function value at pi by 2 is a minus 8. Function value at pi by 2 is a minus 8. And next 1 plus mod cotx to the power of b by a mod tan x. So let's check. F of x is equal to this. See what he says again. It is continuous at x equals to pi by 2. If it is continuous at x equal to pi by 2, left hand limit should be equal. Because of why we are talking about left hand limit and right hand limit? Because of continuity is about pi by 2. So continuity about pi by 2, but pi by 2 left function is different, pi by 2 right function is different. So whenever function behaves differently in left of a point and right of a point, we have to find left limit and right limit separately. But he says that it is continuous, left limit should be equal to right limit. Okay, so we calculate first LHL, which is equal to limit extends to pi by 2 minus, we write for left hand limit minus here. What is the function in left of pi by 2? Function in left of pi by 2 is 8 by 7 to the power of tan 8x divided by tan 7x. Generally we substitute first. Okay, always we use the substitution method while finding the limits. Now here you see, if we substitute x value pi by 2 here and here, what you are going to get? X tends to pi by 2. If you substitute here, you get tan 4 pi in numerator and tan 7 pi by 2 you get in denominator. Tan 4 pi is 0 and tan 7 pi by 2 is infinity. So 0 by infinity is tending to 0. Because of 0 by infinity, you can think like this, 0 into 1 by infinity. So if denominator is infinity, is a very big value, then 1 by infinity is going to be 0. So the final result 0 by infinity is 0 only. So this is going to be 8 by 7 power 0. So 8 by 7 power 0 is 1. So we calculated LHL and we got the value of LHL is 1. Now function value is it's ready, a minus 8. Now we have to calculate RHL. Okay, so RHL means limit extends to pi by 2 plus right side. So we write pi by 2 plus function right side of pi by 2. The function is this pi by 2 to pi. If x lies, then the function is what? 1 plus mod cotx to the power of b by a mod tan x. Now every time we perform substitution method first. So what we do, you substitute x tends to pi by 2. Here we have x and here we have x. If you substitute pi by 2 there, what you are going to get? Cot pi by 2 is 0. So 1 plus 0 is going to be 1. It's 1. And tan pi by 2 is infinity. So it is going to be 1 to the power of infinity form. 1 to the power of infinity form. This limit is going to be in the form of 1 to the power of infinity, which is one of the indeterminate form. But whenever you have 1 to the power of infinity form, what you are going to do, for example, I'll tell you that limit extends to a f of x to the power of g of x. This limit you are calculating and you are getting 1 to the power of infinity. So what we do is we write e to the power of limit extends to a, and we'll bring this g of x function down and we subtract 1 from the base function. So f of x minus 1 we will write. Okay, f of x minus 1. So once again I'll tell you, limit extends to a f of x to the power of g of x you are trying to calculate, but you are getting 1 to the power of infinity. Then we write simply e to the power of limit extends to a. Will bring the power function down. So that what we write down means we write g of x and we subtract 1 from the base function, that is f of x that is f of x minus 1. So limit extends to pi by 2 plus e to the power of, sorry, we should write e to the power of, so I wrote e to the power of, limit extends to pi by 2 plus, we have to bring the top function, power function down, that is b by a mod tan x, and you have to subtract 1 from the base function. So base function is 1 plus mod cotx, you subtract 1 from that, so you get mod cotx. But tan x and cotx are reciprocals of each other, so tan x into cotx is going to be 1. So e to the power of limit extends to pi by 2 plus b by a, tan x into cotx is 1. Now limit of a constant is itself. So this is e to the power of b by a. So we got RHL now. RHL is e to the power of b by a, LHL is 1, and function value is what? A minus 8. So LHL should be, because of continuity, LHL should be equal to, RHL should be equal to function value. Okay. So LHL we got 1, RHL we got e to the power of b by a, and function value already is given a minus 8 in the question. So if you compare these two, you get a is equal to 9. If you compare these two, e power 0 is 1, so b by a should be 0, means b should be 0. And the question is finding the value of a square plus b square. So a square plus b square is a square plus b square is equals to 81. 9 square plus 0 square. Okay. So we'll see some more problems in the next video. Thank you.